Good morning, good afternoon, and good evening. Today we're going to cover the third subtopic of topic 3 thermal physics called measurement of temperature. Temperature. Temperature of an object is a measure of the average kinetic energy of its particles. Because it is the average kinetic energy of a particle, it does not depend on the size of the object. Internal energy and temp can be compared. Internal energy is the total energy of all the particles, and temperature is a measure of the average kinetic energy of the individual particles. Thermometers. To properly use a liquid in glass thermometer and a liquid crystal thermometer, it is important to wait for a minute or two if you want to see the correct reading. This is because the thermometer has probably been stored somewhere relatively cool, like a drawer. If you're measuring something like a fever, it takes time for the thermometer to reach the temperature of the fever. Thermometers are used to measure the temperatures of things like someone's temp to check if they're sick. The temp is indicated by the expansion of a liquid inside a liquid glass thermometer. Temperature in Celsius scale is decided by how far or close it is to 0 degrees Celsius freezing point or 100 degrees Celsius boiling point. Anything in between those two temps are divided into 100 equal divisions. Like each time Anders Celsius was the one who developed the Celsius scale, made a new thermometer. Celsius could calibrate it quite simply by putting it first into melting ice and then boiling water, marking the scale each time. He would then divide the scale into 100 equal divisions. This process is called calibration of the thermometer. Properties of liquid and glass thermometers. Mercury and alcohol are both liquids that expand uniformly when heated and have relatively low freezing points. And mercury specifically has a high boiling point. That's why they're good for liquid and glass thermometers. Describe and explain the structure and action of liquid and glass thermometers. Liquid and glass thermometers are based on the principles of thermal expansion of substances. A liquid in a glass tube called a capillary expands when heated and contracts when cooled. A calibrated scale can then be used to read off the respective temperature that led to the corresponding thermal expansion. We use liquid and glass thermometers to measure room temperatures. Thermometers today usually contain alcohol, but they used to contain mercury. A thinly walled bulb of alcohol called the reservoir is attached to a capillary tube, which has a narrow diameter. When the alcohol expands, it is pushed up the capillary tube. The distance the liquid moves is a way of measuring temperature. So these are the parts of the thermometer: reservoir, the liquid, the bulb, the thing protecting, like thing holding the reservoir, and then capillary tube right over there, liquid, yeah, and scale. Demonstrate understanding of sensitivity, range, and linearity. If the thing you are measuring changes significantly when the temperature changes, it makes it easier to detect small changes in temperature. Your thermometer is more sensitive. The range of a thermometer is the difference between the maximum and minimum temps that the thermometer can read. A common range for liquid and glass thermometers is from -10 degrees Celsius to 110 degrees Celsius. A liquid and glass thermometer is said to be linear if the liquid expands by the same amount for every degree Celsius rise in temperature. This means that the scale will be marked in degrees of equal size as below. You can clearly see the most right is non-linear in the picture, most left is linear. How the structure of a liquid and glass thermometer relates to its sensitivity, range, and linearity. I will show you a video.
Explain how the structure of a liquid in glass thermometer affects its sensitivity, its range, and its linearity. Well, a liquid in glass thermometer comes in two basic types. We either have mercury liquid as the liquid which expands and rises up the tube, or we use alcohol. Both have different characteristics. This is the bulb where the store of liquid is kept, and so when that heats up, the liquid in there expands, pushes the liquid up the thin tube, and we take a reading off the scale, which is on the side there. Okay, so let's take a look at the sensitivity, the range, and the linearity, and how we can influence those with the design of a thermometer. So how could we make a thermometer more sensitive? More sensitive. So what we want here is, for a certain temperature rise, we want a larger movement of that thread of liquid. And the way to do that is, firstly, to increase the volume of liquid in the bulb. So you increase the volume of the bulb. If there's more liquid in there, then when you heat it by a certain amount, more of the liquid will expand, and so more liquid will be forced up the tube, and we'll get a greater rise in that level of liquid. The other way that we can make the thermometer more sensitive to read much smaller temperature rises, remember sensitivity is the smallest change in temperature that you can detect, is to decrease the diameter of the tube. If you have a thin tube compared to a much wider tube, then if that's our level of liquid there, and that's our level of liquid there, then for a certain temperature rise, let's say that our wide tube rises to that much. Well, it's the same volume of liquid that must rise up this thinner tube, and so the same volume will be rising a higher distance. It's like a taller cylinder with the same volume as in the sort of fatter cylinder. So that means we get a larger rise in the level by decreasing the diameter of the tube. We can also use alcohol instead of mercury. And the reason for that is because alcohol expands more than mercury for the same temperature rise. Okay, what about making the range of temperatures that we can measure wider, so we can measure a higher temperature and a lower temperature? So how do we make a wider range? Okay, well, we're going to do the opposite of making the thermometer more sensitive. So we're going to have to make the thermometer less sensitive so that we don't get as much movement in that thread of liquid for a certain temperature rise. So first of all, we're going to decrease the volume of the bulb. We're going to increase the diameter of the tube. And we would use mercury, which doesn't expand as much. So these guys are opposites. If you want to make it more sensitive, you end up decreasing the range over which you can measure. And that's actually a good example in a clinical thermometer, which is very sensitive. It can only measure temperatures close to body temperature, only sort of plus or minus 10 degrees. So its range is very limited, but you don't need it to have a large range if you're measuring body temperature. So that would be a clinical thermometer. Okay. Lastly, how would we get better linearity? Better linearity, which means that the thread of liquid rises and falls by a uniform amount, by the same amount for similar temperature increases or decreases. It doesn't suddenly start to expand more when it gets hotter. How do we get better linearity? Well, we would make sure that the diameter of the tube is uniform. So we'd say a uniform tube diameter. That's important. Remember, as the tube gets thinner, the thread will rise faster. And also, we can use mercury. Mercury liquid expands very uniformly as temperature rises, whereas alcohol tends to have different expansions at different temperatures. So mercury is more linear than alcohol. It's also worth mentioning that if you have thicker glass walls in this bulb and tube, then thermal energy will take longer to reach the liquid. So it will take longer to heat the liquid up, and so its response time will be much slower. So you really want sort of thin walled thermometers to have a quick response time. So there's a compromise. If your walls are too thin, of course, then it could break much more easily. So that's about responsivity. And generally, you need several seconds at a new temperature for the liquid in glass thermometer to register that new temperature. Okay, so that's how we influence the sensitivity, range, and linearity of a thermometer with its design.
Describe the structure of a thermocouple and show understanding of its use. I will show you a video.
A thermocouple uses an effect called the Seebeck effect to measure temperature. In this flashcard, we're going to look at the structure of a thermocouple and look at two advantages of a thermocouple instead of using a liquid in glass thermometer. So first of all, we can say that a thermometer is used to measure temperature. Now, to be more precise, we should actually say temperature difference. And that will become apparent in just a moment. So let's take a look at the structure of a thermocouple. Now, a thermocouple has two different metals joined together at two junctions. So if we were to draw this out, we would see it looking something like this. So we've got our first metal here, which is copper. So this is copper. And we're going to join that with another metal called constantan. So I'm going to draw that in grey. So there's our first junction, literally together, touching. Now then that comes over here and we have another junction, and we'll connect it with the copper. Okay, now these are then fed into a sensitive voltmeter. So this is a sensitive voltmeter. The first junction is called the reference junction. The reference junction. And we should put that in a known temperature, such as in a glass of ice or a beaker of ice. So let's do that. I'm going to put that in a beaker, and it's full of icy water with ice cubes. So we know that that's at 0 degrees Celsius. And that's our first junction. The second junction is our measurement probe. Our measurement probe junction. That's the junction that we're going to measure with. So let's say that that's at room temperature, say at 20 degrees Celsius. When you have a difference in temperature between these two junctions of different metal, and we need to just label that up here. This is Constantan. You can use other metals as well. This is just one example. But when you've got a temperature difference between the two junctions, that creates a small EMF, a small voltage in this circuit, which will cause a current to flow, and we would register a reading on the voltmeter here. So this could be a very sensitive ammeter or a sensitive voltmeter. Okay, so let's just write a couple of words about that so you can understand how it works. We've got if the two junctions are at different temperatures, a small electromotive force, or EMF, remember that's the same thing as voltage or potential difference, is produced. And the larger the temperature difference, then the larger the EMF. So the larger I'm going to put delta T as in difference. Delta stands for change, so difference in temperature. Then the larger the EMF. And that enables us to measure temperature through the voltage that's produced. And so that's a pretty useful effect, this Seebeck effect. So I should just mention that this is copper here again. So what are the advantages of a thermocouple compared to a liquid in glass thermometer? Well, I'll give you three. So the first one is that it has a very fast response time. It doesn't take a lot of energy to increase the temperature of these measurement probes at this junction because there's not much metal there to heat up. It's also very robust, so that it's difficult to break. Very tough. Compared to a liquid in glass thermometer, which can be smashed or broken, a thermocouple is a pretty tough instrument. And that's why it can be used in things such as kilns and gas turbine exhausts, diesel engines, and even flame sensors on your cooker, on your gas cooker, could be a thermocouple. And a third reason why it's very useful is that it's got a very wide temperature range. The Constantan copper can measure between minus 200 degrees and 350 degrees. Minus 200 degrees Celsius, well, that's pretty cold, all the way up to 350 degrees Celsius. That's a pretty large range compared to a liquid in glass thermometer. And in fact, if you use different metals, then you can get a range of temperatures which can go from minus 250 degrees Celsius all the way up to 2,500 degrees Celsius. Now that would be jolly useful in a lot of industrial applications when you need to measure huge temperatures. And that's the thermocouple.
Thermocouple is used for measuring high temperatures and those that vary rapidly.